we'll be starting a new topic today. Yeah, hey. What we want to do would be to solve these linear equations, and hopefully from year 7 and 8 we remember some of those strategies, because remember, maths is not just about the answer, but more importantly it is about the strategy. It's about strategizing. Okay, problem solving and strategizing, that's what mathematicians are good at. Okay, so what we want to focus on when we solve equations is looking for that most efficient strategy. Okay, not all equations can be solved by just one way. There would be different ways, and depending on the equation that you have, there would be a better way of solving that equation. All right, so what we want to do or solve would just be those that we call linear equations. So when you say linear, those would be the equations that would have the index 1, right? We wouldn't have any powers. You wouldn't see any x squared, x cubed there, or you wouldn't see any x on the denominator. So all those that you would see would be just one variable, and also x would be raised to a power of 1. Okay, and when it's raised to a power of 1, you don't see any exponent, any index, any, what's the other one, power. Okay, the question is, how much does a can cost? I didn't like the question, how it was worded out. What does a can cost? How much does a can cost? Okay, therefore the can would cost $3. See, it's not very hard. Even everyone in the social media can do that. And these are what you call equations. Only with equations, we use letters, right? So this topic should be easy peasy, right? We can all do algebra. This is algebra, okay? But they just made it look more fun. Well, letters are fun as well. Okay, so that's what we will be doing. We will be looking for unknowns. We would be looking for the value of that letter, which we call pronumerals. Again, those pronumerals would stand for a numeral, and that's our objective. What we want to know is to find the value of x. Okay, so in year 7 and 8, so this might not be new to us. In year 7 and 8, we did equations, and we solved equations, and we talked about different strategies. Okay, and the most common one we use, which is really any strategy or any problem in mathematics, can be solved initially, right, by guess and check, guessing and checking. It is a valid strategy. Okay, even doctors would use it. When you go to the doctor, she or he would be asking you of any symptoms, and then she would be guessing and checking. Do you have this? Do you feel this? Right? How about if we test this? Maybe it's this, right? So it all starts with guessing, but then you would have to check, right? So with guessing and checking, so that's one strategy that we learned, right? Just like if we would be looking at these questions here, you have x minus 7 equals 40, right? Something minus 7 gives you 40. What's that something? Yeah, 47, because 47 minus 7 gives you 40. So x must be 47. Right? The same thing with this one here. Something, you add 42, you get 55. What's that something? A number that you added to 42 would give you 55. Well, for you to get to 50, you need to have 8, but it's 55. So you go 8 and 5 would give you 13. Right? So 13 plus 42 gives you 55. Therefore, the value of x that we're looking for is what? 13. Okay, so the same thing with this one, but what's the meaning when you have 6x? 6x means what? 6 times x. So when you multiply a number to 6, you get 42. What's that number? 6 times 7, right? 6 times 7 gives you 42, and therefore x is 7. How about something you divide by 8, you get 2. to 16, because 16 divided by 8 gives you 2, right? So that's guessing and checking. It's really looking for what number will make the equation true. When you say the equation is true, the left-hand side is equal to the right-hand side, okay? Now, is there any other number other than 16 that will make this true? Can I have 40 divided by 8? Would that give me 2? No, right? So there's no other number other than 16 that when you divide by 8, you get 2, okay? So that's what we want to look for. We want to find that value of x so that the left-hand side is equal to the right-hand side, okay? Now, sometimes it doesn't make it really easy for us to guess and check, right? Just like maybe some of these equations here. And therefore, we would be introduced with other strategy, okay? Now, the one that I usually get my students to use if guess and check doesn't work, maybe they can do the cover-up method. What does it mean when you say cover-up method? When you cover this bit here, right? So I've got 2y plus 4 equals 12. If I cover this, right? Cover that. Then I've got something plus 4 gives me 12. What's that something? That something would be 8, right? So if I cover 2y, if I cover that 8 plus 4 gives me 12, what that means is that 2y is equal to 8, right? And now you're back to those equations that would be similar to what we did here. You say 2y equals 8, 2 times y gives you 8. What is that number that you multiply to 2 that you get 8? It must be 4, because 2 times 4 gives you 8. Yeah, does that make sense? The same thing, well, 6 minus x equals 8. 6 minus something gives you 8, right? You could probably say what? Well, that's a small number. That's 6, but instead of when you minus a number, usually it goes down. But then this went up. So what can you say about x? X must not be a positive number, because if you minus a number from 6, then sensibly it would go down, but it went up. So what you could say about the number that you minus is actually a negative number, right? So 6 minus negative 2 would give you 8, because when you have 6 minus negative 2 gives you 8, and therefore you could say that x must be negative 2. Okay, let's have x over 3 minus 4 equals 2, right? With this one, you want to get rid of the, or we could probably say something. So let's cover this, let's cover that. Let's use a pink one so it's actually covered there. So something minus 4 gives you 2. What's that something? A number that we minus 4, we get 2. That number is 6, right? So now we can say that x over 3 must be equal to 6, yeah? So now we say something we divide by 3, we get 6. What's that something? The number that we divide by 3, we get 6. It's not 2, because 2/3 is not equal to 6, right? But instead, it needs to be a number that's larger than 3 or 6, right? So it would be a number that's what? It would be 3 times 6, yeah? Right? So then that would have been 18, or x equals 18. Yeah, and as how I said it a while ago, I said, well, that something must be 3 lots of 6. And notice that the operation between x and 3 here is division. but I multiplied 3 and 6. So you could apply here another strategy, which is what we call our inverse strategy. The inverse operation of division is multiplication. So you do the reverse, or what you call your undoing. Yeah. So you undo the divided by 3 by multiplying by 3, right? So you say x equals 3 times 6, you get 18. Okay, now let's use that strategy with this one here. So now we want to get rid of the 5. That means 3x we divide by 5. What's the reverse of dividing? It's multiplying. So we can say it's 3x equals 30, right? Now, what's the operation between 3 and x here? It's multiplication, and therefore the inverse of that would be dividing. So now we divide by 3. Whatever we do on one side, we do to the other so that it's balanced, right? So then we get x equals 10. Yeah? Now we can go, so those are the questions that we would have solved, or equations that we would have solved when we were in year 7 or 8. Now let's have a look at some of those that we will be doing this year. So if you look at these equations here, they would have equations where you've got your fractions, some of it in year 8, but we'll be looking at those equations, harder equations that would involve what? Fractions. So let's start with those ones. We've got x plus 1 over 2 equals 11. But we use the same strategy. We do the inverse. So we do it one at a time. There would be different operations here. One is plus, and then that one is divided. What you do is you get rid of those numbers, what, coming from the farthest to the one closest to your x. So you'd have to divide by, so this is divided by 2. So what you need to do is to multiply by 2 first. Okay, so you multiply 2, so you've got x plus 1, you get 22. Then you can do just cover up method. Something plus 1 gives you 22, then that number must be 21. X equals 21. Yeah. Let's do another one. 7 minus x over 5 equals negative 6.3. Some of it you probably need your calculator, especially when you have what, decimals here, right? So you've got 7 minus x divided by 5. Again, you would want to multiply by 5 for you to get rid of the 5. So you've got 7 minus 5 multiplied by 6.3, oh, negative 6.3 by 5. You can say 6 times 5 is 30, and then 0.3 times 5 would give you what? Is that 1.5? And you add them together, you get, is that 16.5? Let's try, let's see, 6.3 times 5, you get 31.5, or you say it's negative 31.5. Yeah, and so now you've got 7 minus x gives you negative 31.5. Now have a look at this one here. You want to get rid of the 7, right? So that's a plus 7. So what you do is you minus 7 on both sides. And therefore you have negative x equal to, what's negative 31.5 minus 7? That gives you negative 38.5. Now you see both of them are negative. You don't want negative x, but what you want would be a positive x. So if negative x is equal to negative 38.5, what makes sense is that x must be 38.5. Okay. Let's have this one here. This isn't, okay, so you've got 3 over a equals 4 over 5. What you can do here is to get rid of your denominators by cross multiplying. What do I mean? So you multiply a to 4, and you multiply 5 to 3. Okay, so if we do that, we have 5 times 3, we get 15. and you multiply 4 by a, you get 4a, right? And for you to get rid of the 4, you divide both sides by 4. You get a equal to 15 divided by 4 is the same as when you say 15 divided by 2, and then divided by 2 again, or you can also just use your calculator and say that that's 3.75. Okay, let's do that one last one there. 5 over b equals -2, right? So again, you can do, you cross multiply there. You could say it's the same way as what we did here. You cross multiply there and multiply here, but what you know is that the denominator is 1. So save yourself from all that trouble. Just multiply the other one, just the one that's got the denominator. So you've got 5 here, and then you multiply the b to the -2, and therefore you have -2b. Now you want to get rid of the -2, you divide both sides by -2, and therefore you say b is equal to -5 over 2. You can leave it as a fraction, right? You can leave this as a decimal only if it has a decimal, it's terminating, but the preferred answer is actually a fraction. Just leave it as a equals 15 over 4. Okay, so either of these would be correct. Okay, yeah. All right, so these are the actual work examples from your textbook. And we're looking to chapter 10 now, so it's 10.2 of the exercise.